3.2, solve linear systems algebraically.
I can't do these math problems. Why am I so stupid? If 2x plus y equals 60 and x plus 2y equals 75, solve for x and y. How the heck do I figure that out?
If 2 shirts and a sweater cost $60 and a shirt and 2 sweaters cost $75, what does each item cost?
The shirts are $15 and the sweaters are $30. Duh.
You aren't stupid, Paige, just weird.
Come back. You still haven't told me how to solve the problem.
So let's go ahead and do what we were doing last lesson, except let's do this algebraically. So first we're going to solve using the substitution method. The substitution method, which I'll explain on the next slide, is that you solve one of the equations for y equals and then you plug it into the other one. So this equation here looks very easy to get y equals all by itself, so I'm going to just go ahead and manipulate this equation, add 2x to both sides, and come up with y equals 2x plus 4. So now what I'm going to do is everywhere I see a y in this equation here, everywhere I see a y, I'm going to stick this in because we know now y equals 2x plus 4. So instead of a y, we can put in a 2x plus 4. So now we have 3x plus 2y is equal to 1. Let's distribute. Plus 4x plus 8 equals 1. Combine like terms. Scoot that 8 over to the other side. And we have x equals -1. Now we need to find y. Well, since we know already that y equals 2x plus 4, why don't we just plug it into that equation? So that would mean that y equals 2 times -1 plus 4, which is equal to -2 plus 4, in other words 2. And so our answer is the point -1, 2, or you could say x equals -1, y equals 2. Now it doesn't matter which equation you plug this -1 into. If you plugged it into this equation, or this equation, you must get the same exact thing. You could do that to check. So in summary, the substitution method is where you pick one of the two variables, solve for one of its variable. Usually I solve for y. Substitute the expression from step 1 into the other equation, which is what I just did. Instead of y, I put in all x stuff. Then you solve that equation, and then you substitute the value from step 3 into the equation from the other variable, which you found in part 1 where you solve for y, and you solve it. So those are kind of your steps. Let's go ahead and do one more using the substitution method. So in this one, which one looks like it's easier to solve for y?
The second one, y is all by itself.
So we would subtract 4x from both sides, and we get
y equals -4x plus 24.
And so then, in the first equation, instead of y, you're plugging in this. So we have
2x minus 3 times -4x plus 24, in parentheses, equals -2.
Now we've got to distribute that -3, and we get
2x plus 12x minus 72 equals -2.
Combine like terms.
We have 14x minus 72 equals -2.
Scoot the 72 over there.
14x equals 70.
And we get?
We get the answer of 5.
And so if x equals 5, then y equals?
Y equals -4 times 5 plus 24 or negative 20 plus 24, which would be 4.
So our answer is x equals 5, y equals 4, or you can put it in an ordered pair and say the 0.54 is our solution.
Okay, great.
All right, so let's go ahead and solve this one using the elimination method. So in the elimination method, really what you want to do is you want to be able to add both of the equations so that one of the variables cancels itself out. And what I mean by that is that it sums up to 0. So if I added these two, for instance, I would be getting 6x plus 5y equals 17. You see, I haven't gotten 0x or 0y. That's not what I want. I want to eliminate one of the variables, which is why it's called the elimination method. So let's say, for instance, that I multiply this guy by 4. Now let's see what happens. So rewrite the equation as it was. And then for the second equation, multiply everything by 4. So we get negative 8x plus 12y equals 4 times 3 is 52. Now look what happened. When we add them, we get 0x, which is exactly what I wanted. I've now eliminated my x variable. That's why it's called the elimination method. So then we get 56, divide by 14, and we get y equals 4. So now we need to get what x equals. You can choose either equation in this case. The first one looks simpler to me, so I'm going to just choose it. So I have 8x plus 2y equals 4. Remember that y equals 4. Let's go ahead and put that 4 in for the y. 8x plus 2 times 4 equals 4. 8x plus 8 equals 4. 8x equals negative 4. In other words, x equals negative 1/2. So our solution would be negative 1/2, 4, if we want to write it as an ordered pair. So the elimination method, in summary, is saying multiply one or both. You might have to multiply both. In that other one, we just had to multiply one of the equations by a constant to obtain coefficients that, when added together, will cancel out or add to 0. Add the equation from step 1. Combine like terms. We'll eliminate one of the variables. In that last equation, we just eliminated our x's by doing that. Then you solve for the remaining variable. We solve for y. And then substitute the value from step 3 that we just got into either one of the original equations. It doesn't matter. Solve for the other variable. Now look at this comic here. X plus y equals 3 is saying to 2x plus 2y equals 6. What a coincidence. How embarrassing. Well, it's like they're wearing the same dress, right? Because if we multiply this guy by 2, we get 2x plus 2y equals 6. So never want to be wearing the same dress to prom or anything. All right. Let's try this one, solve using the elimination method. What does it look like? Can we multiply the top by anything to get the bottom, or the bottom by anything to get the top?
It doesn't look like we can do that in this these two problems. But I do see that there's one, the top one's positive and the bottom one's negative, so that's good. So if we can get them to be the same value, we could multiply the 4 by 3 and the negative 3 by 4.
Okay.
And that'll do it.
So then we would get 12x and we would get negative 12x, and those would cancel out. Okay, let's do it.
Okay, 12x minus 9y is equal to 75. And negative 12x plus 32y is equal to 40. Adding those, we get 23y is equal to 115.
Divide by 23.
Let's see. And we get 5.
All right, and then the next step was to plug it into either two of the equations. Which one do you want to choose?
I'll choose the first one. 4x minus 3 times 5 is equal to 25.
Okay, so you just plugged the 5 in there. And then that would be minus 15. Add 15 to both sides.
4x equals 40. And x then would be equal to 10.
So our ordered pair is 10, 5.
Right.
So let's just prove that this works actually for this one. Let's just make sure we did it right. Does negative 3 times 10 plus 8 times 5 equal 10?
Okay, negative 30 plus 40 equals 10.
It does. 10 equals 10. All right, and we had put it into the first one, so that obviously worked.
Yay.
All right, last problem.
Okay, at a pizza restaurant, it costs $4 to make a small pizza that sells for $12. And it costs $6 to make a large pizza that sells for $15. In 1 week, the restaurant spent $1,100 making pizzas and sold all of them for $2,910. How many small pizzas were sold?
Well, let's call X the number of small pizzas. And Y would be the number of large pizzas. And so it said that in 1 week the restaurant spent $1,100 making pizzas, and it cost $4 to make the small and $6 to make the large.
So 4x plus 6y has to equal $1,100.
Because all those things were dealing with my cost, right? And then my other thing that I have is pretty much my revenue, right? And what is that?
Okay, so the small ones are selling for 12, so that would be 12x, plus the large ones are selling for 15y, and the revenue is $2,910.
Okay, now we have two equations. Oh, look at this. We have a 4, and how can we make 4 into a 12? We'll multiply by 3. Of course, we want this one to be negative, so let's go ahead and multiply this guy all the way through by negative 3, in which case we'll have
negative 12x minus 18y is equal to negative 3,300.
Keep the bottom one as is. Add them up, and we get
negative 3y is equal to negative 390.
Divide by negative 3, divide by negative 3.
And y comes out to be 130.
130. So we sell 130 of the large pizzas, but they asked us how many small pizzas were sold. So let's just choose the top equation. 4x plus 6y was 130. I'll plug that into the next step so you don't get confused. So I'm going to just plug this in there. And so I end up getting 4x plus
780 is equal to 1,100. So 4x is equal to 320, making x equal to 80.
So that means we sold 80 small pizzas. So let's go ahead and solve these systems. So in this question here, it looks like we would want to use the elimination method because we don't have y equals on either of them. It doesn't matter which one you choose to use, but this one looks like elimination would work very nicely if I just multiplied this top one by, let's multiply it by negative 3 so that we would get the negative 6's canceling out. Negative 6x plus 9y equals negative 12. Leave the bottom one as is. Add them up, and we get, 0 equals negative 4. When's the last time you heard that 0 was equal to negative 4?
Not in my lifetime.
No, so these would be inconsistent. In other words, that they're going to actually be parallel lines. If you put them both in y equals mx plus b form, you would see that. So these are inconsistent. There is no solution. All right, so let's do this one. What does it look like we should use?
That one is just made for substitution.
Yeah, we put this instead of y in this equation. We're going to just stick in this x minus 4.
So, negative 6x plus 6 times x minus 4 is equal to negative 24. And negative 6x plus 6x minus 24 equals 24. Well, minus 6x plus 6x is 0. So it looks like the left side is negative 24 and the right side is negative 24. Well, negative 24 always equals negative 24. So it looks like we're talking about the same line, which is called consistent and dependent. Therefore, the solution is any number that is on the line, or infinitely many solutions.
They are just the same line.
Mm-hmm.
And that's it for this lesson.
Bye.